Hi everybody, Benjamin Ashwell. I'm here to be excited to be here today to talk about the work we're doing in DOD Sustainment. See when the slides come up. Do I need to do something on here?
Yeah. You can pull up the slide.
Okay.
Yeah.
I got you. Okay. All right. Here we go. Excellent. All right. So this is actually a great act to follow because I don't need to explain to you the importance of reproducible workflows. That's been well handled already. I'll say that in addition to being able to share with people and check things, another bonus is it gives you a lot of flexibility. You have the tools in place, you have the data, you have a setup, and it makes it easy to come back and change things. It means that every major analysis is not a bespoke effort. It's not a one-off. It's now an investment in future capability. But you have to build that in up front. What I'm going to be talking about today is a large workflow we've built. It's taken a couple of years to come together, but it's really given us a lot of analytic firepower that is, I think, benefiting our sponsors in the DOD. So, talk about readiness. Readiness means, can the ships, planes, trucks, things we own, do they work? If the war starts today, do they work? Can they perform their mission? Readiness is a persistent challenge for DOD weapon systems. So if we go back a couple of years ago, then Secretary Mattis ordered all fighter jet readiness across the DOD should reach 80%. What that means is, of all the fighter jets we owned, at any given time, 80% should be able to fly. That's actually a reasonably steep requirement. It's reasonable but high, just given the way these things get used. They get put through their paces every day. So 80% may not sound very high, but that's a achievable but high goal. He said, okay, everybody, you have 1 year to do this. A year later, for the F-22, it was flatlined. Nothing changed. Nada. So, you know, with a respected and Secretary of Defense saying, you'll do it, and people did try. No one ignored him, but the needle didn't move. Why? Why is readiness so difficult to maintain? Okay, so hopefully I've motivated why this is an important problem. But there's another layer. It's also a very, very, very expensive problem. We spend most of our time thinking about the cost of new systems, of F-35s and carriers, and those things are pricey. But if you actually look at the DOD budget, a good 40% of the budget goes to paying the people and maintaining the systems we already own. Comparatively, only about 20% goes to new procurement. So 40% of the budget is paying for the people who are in large part maintaining the systems and the maintenance of the systems themselves. So this is a problem from a operational perspective because the numbers are lower than what we'd like them to be, and it's a problem from a financial perspective. We are paying through the nose and still not getting what we want. Okay, so what we want to do is to tie resource decisions to readiness outcomes. To be able to say, if you spend $100 million on the F-18 and you spend it this way, this is the kind of flight line readiness you expect to see. Or to say, NAVC is going to get cut $80 million in this color of money next year. Where should they cut it from to have the smallest impact on readiness? How do you actually, because right now there is not a systematic way to look at these things. It's very anecdotal. Okay, so what do we want to do? Well, we're analysts, so we want to bring our suite of analysis techniques to bear here. We have a toolbox for this kind of thing. We want to make good decisions. Okay, how do we do that? Cross-cutting data analysis. This is fancy speak for getting your data and communing with it. Just sitting there and just figuring out what your data mean. What does it mean when the malfunction code is an 801 or an 814? What does it mean the action taking code is this? Get it in one place, learn it, and see the ground truth story it tells. You can do correlative studies. This is everything from y equals mx plus b linear fitting to machine learning. This is letting your data tell a story that you don't know the answer to start with. Very powerful. Another thing that actually we specialize in, not going to talk too much about it here, but this is the perfect opportunity. Then in the next session, one room over, The rest of my team is presenting on the actual nuts and bolts of what we're doing. I'm here to talk about the workflow, the benefits of data, reproducibility. They're going to be talking about the actual analysis we're doing. So if you want to hear more about the simulation, there's a talk next door after this on that very topic. Okay, so we want to do all of these things. We have all these tools in the toolbox. There's one glaring problem. No single person or organization in the entire DOD has an end-to-end picture of the sustainment system. Nobody has all the information they need to make the decisions. I've said this in front of admirals, generals, never been contradicted. Usually people start laughing because it's true. And it's I'll show you, it's not for lack of effort. It's not because people aren't trying. It's not because people aren't smart. It's because it's a big problem, and it's nobody's problem right now. Okay, so how do we end up in a situation where no single person has the need? Okay, access to data is often limited. The databases are stovepiped, and many organizations are reluctant to share data even within the same service, sometimes even within the same building. I'm not here for a psychoanalysis of DOD culture. It's a big place, and not everyone sees eye to eye on what they should be doing with their data. And this is true, I'm sure, of any large organization. So step one, just getting your hands on the data is difficult. Step two, knowledge is stovepiped. These databases often have their origin, say, in the 60s, so the naval maintenance records are punch card formatted still, because it's the same reference as the 80-character IBM punch card. Same format. Why change it? But that means you have cryptic codes, you have things, you have to decoder rings, you have to kind of know how to read the tea leaves because the E2 community fills these things out differently than the P8 community, so this code means something different. Knowledge is often tribal. Having the data is not enough. You have to understand it. I'm going to foot stomp this a couple times. You have to understand it. And finally, this is a big problem. The DOD is a big place, or even just the Navy or naval aviation. To zoom into that tiny corner of actually a very massive part of the budget, naval aviation, big enterprise. Fixing this data problem requires a systematic, long-term effort that crosses a bunch of organizations. So to name drop some, NavSup, NavC, NavAir, CNAF, DLA, places that don't always see eye to eye about their interactions. Another problem is there's nobody who owns this problem. There's nobody who actually all these groups report to until you get to the SecDef level who does not manage this kind of detail. Okay, so we have a problem. We want to obtain ground truth on real-world sustainment, process the data, and enter into a simulation. If we didn't have a data problem, this is what we would do. We'd get maintenance data, operations data, spares data, reliability data. We'd process it, we'd rename columns, we'd calculate averages. We'd throw it into a simulation, we run the simulation, and then we'd learn. Step 3, profit. But this is actually quite difficult to achieve in practice because of the data problems. So let me give you a semi-concrete example. Names have been changed to protect the guilty, but when we started on our first analysis project, we were told these were the databases you needed to go to. Go to these 4, it's actually 3.5. Go to these databases, and you will get what you need. A year later, we went back and briefed leadership that this is what we found in the actual data system. This is the actual connection of things. And this is true for every service or every piece that I've seen. And one thing I want to emphasize, the problem is not that it's complicated. Of course it's complicated. The Navy or the Army, of course it's complicated. The system it is recording information from is complicated. The problem is that it is stovepiped, that knowledge is tribal, and nobody owns the whole problem. There is no ground truth anywhere in here. So, but let's say you actually make friends, and say, oh, could you please pull this data for me? Could you pull this data? Could you DOD safe this to me? And actually you get people to send you data, and you're under the table, and you find some chiefs who would be friends with you and who will explain what columns mean. Okay, you've finally done that. You finally have data. Bad news. There's no ground truth there either. There are different ways to interpret the data. So you get your raw data, you shove it into your processing pipeline, and you end up with different possible values for the same metric. This is a real example. These are real parts. Different databases have different numbers. Now, I'll tell you, some of these numbers are wrong. Some of them are right. More than one of them are right. but they're different questions. Things like what is the demand at the local level for a spare or at the national level, because there may be local repairs that keep spares turning over locally. It may not differentiate between failure and demand. Not all failures generate a demand for a replacement. Software is just rebooted. There's no demand. So what's the truth? And this is why, again, when I foot stomp, having the data isn't enough. You have to know what it means. Okay, so in summary, the first half, no single person or organization in the DOD has an end-to-end picture, and it's driving bad decision making. So what are you going to do about it? We built a data processing pipeline that creates an end-to-end picture. So I'm going to walk you through what this is. This is all written in R, and this is code on our networks. Step one, collect raw data. I've already made my joke about asking nicely, but that really is mostly what it is, asking people nicely to send you data until you figure out what it is and maybe get a data sharing agreement. So step one, get the data. Okay. Step two, curate the data. I'm going to introduce the first of our cute little packages. We are dedicated to our puns, so they're all animal themed. So this is Nectar. It is our upstreamist. It's our pre-processor. It's the step where you curate the data. It's the step where you go, okay, last time I'll give you a concrete example in a few slides, but last time this was a year, month, day, we need it day, month, year, whatever, that you need to make sure that the data is in the same format every time you get it so it goes through the same processing pipeline. Nectar is the pick and shovel work of getting the data, filing it in the proper date, checking these things, and then turning a crank to actually get everything lined up. It's a time-consuming process, but it is vitally important. Okay, but that's just, as I said, mostly just data management stuff. The next step, this is the big one. This is the step where you take the millions of maintenance records, the thousands of requisitions, the thousands of contracting actions from NAVSUP or DLA or AFLM, jeez, you can never get that one, the Air Force Logistics Command. And actually you crunch it. You group and summarize. You apply logic. You throw away records that are junk. You try to develop ground truth. We have different packages. Saberwing is for the Air Force. Swordfish is for maritime. Honeybee is for naval aviation. They all have specific rules and logic based on discussions with SMEs to figure out from the raw data what is a reasonable truth. There is no perhaps ground truth we can measure, but how do we get something that produces a reasonable answer based on the data in the system? So these packages each are maybe 7,000 or 8,000 lines of code. There's a lot of logic in here, but it's a package, it's version controlled, it's documented, it's repeatable. And finally, a little less important, but now we have the data, let's do something with it. So in this case, we're using a tool called Stinger to build a model, to actually build inputs for a stochastic simulation that we will talk about next door in the next session. Okay, so the processing pipeline is just as important as to our support to the DOD as the actual results. So to say it again, the analytic results we do, they're useful, but just having the data in one place answers half the questions right away. Questions answer themselves when you actually have all the stuff in one place and you understand it. I'm going to skip. Nope, this is the right order. Good. All right. So I'll pause for questions. I'm going to give you an example of steps 2 and 3 in a minute, but any questions on what we're doing or why we're doing it? All right. I'll take that as a good sign, I hope. So this is a reproducible process. Every time we get new raw data, so if you're familiar with naval aviation, deck plate is the maintenance record repository. Every time we get a new dump of deck plate data, we save it to a folder with a specific date, and then you begin the process. You turn the crank, and Nectar goes through Nectar, is now pre-processed, goes through Honeybee, and now it's post-processed. We have item-level metrics, NIN, if you're familiar with the term, part number level metrics. And now you turn the crank some more, and now you have a model input that simulates, say, the entire F-18 fleet, or the P-8s, or the E-2s, with deployments and dynamic flight operations and the wholesale system kicking in to provide new spares. When new data arrives, very little human intervention is required other than filing it in the right place and hitting run a couple times and waiting Nectar takes a couple hours, you do it once a month. Honeybee takes 45 minutes, you do it once or twice a month. Stinger takes about 90 seconds, you do it as often as you want to make a model and change various parameters. It's reproducible with the same data in. We get the same model out every time. And every time we get new data, we get the same structural model out. Now, the failure rates may have changed, but the raw data were interpreted the same way they were interpreted last time. And any bugs are still there, or not. If it's a bug, it's consistently buggy, which is good. The worst thing any program will tell you is, wait, this shouldn't be working. Why is this working? That's terrifying. It's a stinking feeling. If it's broken, it should stay broken until you fix it on purpose, and then you know, and you write a little note to yourself. Everything before this day is invalid. But it's consistent, and that's really important, and you'll see at the end, but we're supporting multiple weapon systems. It's really important that all of them are on the same footing, that we don't have fundamentally different rules for modeling the F-18 than we do for the P-8. They use the same data systems. They should be treated similarly. Okay, so what's actually happening in step 3? Well, you're taking raw data, database 1, 2, 3, 4, so that's deck plate and AFAST, or it's LIMS EV, ILSS, IMDS, or it's raw transactional data, requisitions, maintenance action, contracting action, stock levels, and you're throwing it into the calculator. You turn the crank, and it's calculating things like demand rates, the risk of an abort, meaning if this thing fails in flight, what are the odds of an abort? And this is all aviation examples, but we do maritime as well. So what are the odds that if this part fails, it causes the ship to return to port, or at least abort its mission until things are restored? There's a lot going on behind the scenes here, and this is a very important step. Okay, so what does this actually look like? I'll give you 2 quick examples just to show you when I say that there's in-the-weeds stuff, there's a lot of data munging, what do I actually mean? Okay, so Nectar. This is that first code step I mentioned, the pick and shovel heavy lifting. I'm not going to read through this in detail, but just to give you a flavor, okay, so we got repair and procurement contracts from NavSup and DLA. We got the fresh data dump, first of the month. Okay. Well, 2 different commands, different column names for the same things. Got to rename them. NavSup calls it NIN, and DLA calls it material. It's lowercase over here, it's uppercase over here, that kind of thing. Just got to get them on the same footing. Also, it might change from pull to pull. If a different person pulls the data this month, maybe it's got underscores instead of spaces. This happens. So just got to get all your ducks in a row. Another example is DLA does not do repairs. They do procurement only. So they don't have a repair or procurement column. We need to add one in and set it to procurement so it joins correctly on the other data. Got to change date formats. Got to fix missing values. Got to dump everything that was before 1970 because that's a Unix time error. Okay. I mean, boring stuff. But you have to do it right every time, and you have to do it the same way every time. And we used to do it kind of bespoke, and it became nightmarish. We could do it, but it took a tremendous amount of time. We built a workflow. Okay. Steps are important to get right, but require a little expert knowledge. Now here's the fun stuff. This is the modeling philosophical stuff we'll talk about next door after this. But the stuff that analysts live for. What do the data mean? So AFAST is every requisition in naval aviation. When the maintainer orders a paperclip or a new jet engine, they fill out a form and it gets logged because money is going to change hands. Which of these requisitions count from the perspective of our model? Because this tracks also item movement. If a supply officer at Lemoore ships something to Oceania because they asked nicely, that shows up in this database. It's stock movement. But that's not a demand. No part got eaten. It's just you're just rearranging stuff. So we need to cut those. I can go on, but through trial and error and talking and looking and kind of following our nose, we developed rules to say, you can read them for yourself, but if it fits any of these criteria, throw it out. This demand was real, probably, but didn't count from what we mean when we say a demand for the purposes of our model. Developing these steps required a detailed understanding of Navy databases, the sustainment system, and what we meant when we said, in this case, demand. Because different people mean different things when they say it. So it was super important to be precise for this intended use of the model. Okay, so now that we've done that, and there's thousands of lines of code of this kind of stuff, but That's the idea. So now we have a way to get from A to B. We can take the previous balkanized databases and come up with an answer we think is meaningful for the question we're answering. It's not a right answer machine. I like to call it a reasonable answer machine, in that every item in the Navy or the Air Force has a just so story behind it. They're all different. They all have their own quirks. But based on the data in the authoritative databases, this is the most reasonable, one-size-fits-most interpretation of this item. And because on a Super Hornet, say, we're modeling 1,000 unique major assemblies, that means that we can't analyze each one in a bespoke manner. There's not enough time in the day. We have to apply a general set of rules. And similarly, and we'll talk about this in the next session, another cool thing we do is, rather than saying, well, it takes 300 days to make something, in real life there's massive natural variability. So we actually fit it with log normals or Weibels and say, there's real life variability. You get lucky, you get unlucky. We can put those fits, that natural variability, into our stochastic model and actually help to better evaluate risk that the DoD faces. Okay, so we have these rules that are written down, they're coded, they run the same way every time. And what this means is, because all of the heavy lifting is built into a code back end, we can build new models relatively quickly. So the Super Hornet model, our first, took us about a year to build. We had to teach ourselves everything. I have some funny stories about being really kind of blank stares from people saying, based on what we didn't know. We had to learn a lot. It took a year. The MH-60 model, the helicopter, 6 to 8 weeks, because all the tools were there. All we needed was subject matter expertise on what makes the MH-60 different than the P-8 and the V-22 and the E-2. What are the operational nuances? To give you an example, F-18s do one thing. They go on carriers and deploy. MH-60s go on everything: destroyers, cruisers, LCS, amphibs, carriers. Their life cycle is very different. Got to put that in the model. We also use similar tools not discussed here to build maritime models, but same basic idea. So, I'll mention in passing, the simulation software we use is called Simlox. Some people may have heard of it. We'll talk about more in the next session. But the actual calculator at the end of the chain is the least important part. You need to know the same information regardless of what stochastic model you're using. You have to know the failure rate. You have to know the price of the item and the lead times. You have to know how many maintainers you've got. What column you put it in the final calculator is important in a technical sense, but not in a philosophical sense. Our analysis pipeline would change very little if we had a completely different simulation. So, last slide, I just want to say, to come back and hit, the point of what I showed is trying to tie cause and effect. We're trying to help the DoD tie resource investments to readiness outcomes. If I move this lever with money, or with people, or with changing operational plans, if we go to war, if any of these things happen, what does that do to the actual ships and aircraft? Not to intermediate metrics like range and depth, if you're familiar with those, or fill rates, but to actual mission readiness. And the only way to do that was to actually build an end-to-end picture of the sustainment system. And this took a while. I mean, we've been at this for 3.5 years. And I mean, we've been in a pretty good place for a little while now, but it took us a year. The crawl phase was a full year. If I'm being generous, maybe we're now in the run phase or late walk. But I mean, this is a major endeavor, and we're really grateful to our sponsors in OSD Cape, in the Navy, and in the Air Force, who have given us the patience and support while we built this up and didn't say, if you don't have something in 90 days, you're dead to us. So the long-term investment is a very real part of this, but now that it's here, I use the term unparalleled analytical flexibility, and I mean that. Could we have everything in one place? We can answer questions quickly just by virtue of having the numbers and knowing what they mean. And it's a huge force multiplier in terms of being able to answer important questions quickly. So it's work I'm really interested in, and I'd be happy to answer any questions.
Hey, sir. My name's Alex Camp, work on the Joint Staff, J3. Fairly intrigued with what you do because I do something similar from a ballistic missile technical collection standpoint. The assets that are responsible for that type of collection, bringing data in from multiple places and spaces, and having something there to answer the question. Just as you alluded to, having be able to be Johnny on the spot to answer questions. My question to you is, and I acknowledge maybe this is something for the next session, but just how receptive have your customers been with the outputs that you've been able to generate to answer questions? Because what I have found that has been somewhat frustrating is the fact that I'll look the customer in the eye, I'll give them the information, I'll even show my work like I did in algebra when I was a kid, and say this is what here's the backup, and I just get the yeah thanks, and then move on because there are other considerations, as General Schwartz indicated. There are other considerations decision makers have to keep in mind. But I mean, from your experience, how receptive have your customers been?
I would say, fortunately, in general, very receptive. So there, as I mentioned, not everybody gets along all the time, and so there are certain groups where we're not the most popular people because our answers might disagree with their answers. But I would say that generally we've had a lot of success with saying, look, here are the numbers, here are the rules. Either our interpretation rules are wrong, in which case tell us the way to do it, or the raw numbers are wrong, in which case who owns it? If someone needs to go fix it, or the numbers are right. The only so many things can go wrong. And yeah, we've been lucky. There's been a lot of the thing people are receptive to really is having it all in one place and understanding it, not just collecting it. Anyways, the Seinfeld bit. You can take the reservation, but you can't hold it. It's like getting the data; it's interpreting it.
All right, let's thank our speaker one more time.